right, doing this problem called linked list cycle. Essentially, we are given a linked list and you need to find if there is a cycle in it. Now, if I had not seen this problem ever or did not know about the algorithm, the approach that would come to my mind would be, hey, just walk through the linked list and save every element or the save every node in a hash set and check while traversing, hey, is this node already present in the hash set? And if yes, then it's a cycle. That would be the simple algorithm that I would come up with. But obviously, there is a follow-up here. You can use that, but there is a follow-up saying, can you solve it using O of one constant memory? So meaning that you really can't use a hash set in that case. So now to solve that and finding a cycle, there is obviously a nice algorithm called Floyd's cycle finding algorithm. Let's quickly talk what it does. So essentially, let's take a look at the example input. So the example input is 3 and then 2 and then 0 and then -4 and there is a cycle. So what this cycle finding algorithm does is sort of similar to how you would find like a middle of a linked list, which is essentially you take two pointers, a slow pointer and a fast pointer, and you just uh, and then you just walk. Like one pointer will move one step, another pointer will move two steps, and eventually, if both pointers reach null, or if any pointer reach null really, then clearly there is not a cycle. But if you don't reach a null, and then these two pointers will at some point meet, and when they meet, you can say there is a cycle. So let's take one example where first there will not be a cycle. So let's take a basic example: 1, 2, 3, 4, 5, and null. And so essentially, what you will do is do you have a both slow and fast pointer at the same position, but this is how the fast will go and this is how slow will go, right? So essentially, you will go. Um, so the fast will move something like again same 1, 2, 3, 4, 5, and it will then reach null. And slow will walk something like 1, 3, 5, and it can't go further. So at this point itself, you'll say, hey, I'm done, right? I can't do anything else. So overall, n by 2 time it will take you n by 2 time to figure out that you reach a null from the, sorry, it's the, okay, the reverse thing, but yeah, you get the idea. Now, similarly, let's do the same for these list with the cycle, right? So let's have a fast pointer, and let's also have a slow pointer. And both starts with the head, but the fast pointer will keep moving one step, so it will go 3, 2, 0, -4, then it will enter the cycle. So 2, 0, -4, 2, 0, -4, something like that. And the slow pointer will get two steps. So after 3, it will go to 0. Then after 0, it will go to 2. Then after 2, it will go to -4. Hey, what? They meet. So if they meet, there is a cycle. As simple as that. All right. So let's quickly write the code for this. So what we do is we have a slow pointer. So this node slow pointer, it also slow pointer, it is at head, and you also have a fast pointer which is also at head, and you do while. So fast pointer should not be null. Slow pointer also should not be null. And also for the fast pointer, fast point again, I made that mistake of fast and slow, where fast was moving one step and slow moving two steps, but you get the idea. So fast pointer, because it makes two steps, that means you want to do fast pointer is equal to fast dot next dot next. So you also want to ensure that its next is also not null. All right, and if all of this is happening, then you do okay, so you do slow pointer equals to slow pointer dot next, and fast pointer equals to fast pointer dot next. And if you do this, and if you get them as equal. So if slow pointer equals to fast pointer, then you will return there is a cycle, otherwise there isn't a cycle. All right, submit, and it works. Cool.